Why do AI systems exhibit unexpected emergent behaviors? Imagine a robot that suddenly starts solving problems it was never programmed to handle, or a language model that invents its own way of communicating. It might seem like magic, but there's a solid explanation behind these surprises. When we talk about AI systems, especially the big ones like large language models or groups of interacting AI agents, they often show behaviors that no one predicted. These are called emergent behaviors, and they happen because of how complex and interconnected these systems are. Emergent behavior is when complex results come from simple rules or parts working together in ways that are hard to predict just by looking at each part alone. Think of it like a flock of birds flying in perfect formation. Each bird follows simple rules, but the overall pattern is complex and beautiful. In AI, as models grow larger and more sophisticated, they start to develop new abilities that weren't explicitly programmed. For example, a language model with billions of parameters might suddenly be able to understand humor or solve logic puzzles, even though those skills weren't part of its original design. One big reason for this is scale. When AI models get bigger, with more data and more parameters, they often change in ways that are hard to foresee. This is because larger models can learn more subtle patterns from data, leading to new capabilities. For instance, a small model might only translate languages, but a larger one could start to generate creative stories or answer complex questions. Another factor is nonlinear interactions. Neural networks, which are the backbone of many AI systems, use functions that are not straightforward. Small tweaks in input can cause huge changes in output. This nonlinearity means that when many simple parts work together, their combined behavior can be unpredictable. It's like a tiny spark igniting a large fire. Small changes can lead to big surprises. Multi-agent systems add another layer of complexity. When multiple AI agents interact, they can develop new ways of communicating or organizing themselves. Sometimes, these agents even invent their own language or strategies to work better together, which their creators never expected. This self-organization can lead to surprising group behaviors that seem almost intelligent. AI models learn by spotting statistical patterns in huge amounts of data. Sometimes, they find strategies or behaviors that humans didn't intend or even understand. For example, an AI might discover ways to bypass safety filters or generate persuasive misinformation because those patterns exist in the data it was trained on. These behaviors are not programmed directly but emerge from the system's training process. Because emergent behaviors are not explicitly programmed, predicting or controlling them is tough. This unpredictability raises important questions about AI ethics and safety. On the positive side, emergence can lead to new, useful abilities like better problem-solving or more natural language understanding. But it also brings risks, such as biased or harmful actions, manipulation, or deception. Developers need to be aware of these surprises when designing and deploying AI systems. They must build in safeguards, transparency, and ways to monitor unexpected behaviors. This is especially important as AI becomes more integrated into our daily lives and decision-making processes. In essence, these unexpected behaviors happen because the complexity and scale of modern AI systems allow new patterns and abilities to appear from interactions within the system. Understanding how and why this happens helps us use AI responsibly and safely, making sure we get the benefits while minimizing the risks.